section's on 7.2, and we're going to go ahead and do the last part of this section, and this is called the inverse and matrix. So the last section we did the second order of determinants, and we also did a third order of determinants. So we're going to use the second order determinants to do a couple more steps to find the inverse. So let's go over that. So if you remember on the second order of determinants, we had something like this, where we had a matrix, and then we had is A1, B1, A2, and B2. And to find a determinant, we had a cross multiply right here, and then the operation was minus, right? And then we had multiply on the other side right here, okay? So we're going to use that same idea, but we're going to continue on with that same of the second order determinants and add a couple more steps. So finding the inverse of the determinants, what we're going to do is we're going to put A, and there's a little -1 on the notation. That's going to tell me that this is an inverse. So make sure you put a -1, okay? Then we have is 1 over the determinant. The determinant, remember, was the result of this right here. So that's the 1 over determinant. And then we also have to fix our new matrix. Now, pay attention to this. The notice is this is B2 and this is A1. So what happened with this A1 and B2, they switched position right there, okay? So that's the switching of the position right there. And then the B1 and A2 is exactly the same location. That has not moved, but you did put is a negative on each one of those, okay? So this is now the new setup right here. And then from here, we add or we multiply the 1 over determinant to each of these cells right here to get our final product, all right? So let's try this example 1. So example 1 I have is 8, 4, 7, and 6. So the first step is to find the determinant, which is the second order determinant. So we multiply across 8 times 6 right there, minus the 7 times 4 right there to find the determinant. So that's going to be the setup right here. When I simplify that, I'm going to get 20. Okay? So now again, that's just the determinant. So now to find the inverse, I take the 20, and we're going to go 1 over 20, because that was the determinant. We switch the 8 and 6 position. If it was negative or positive, you go along with it as well. So the 8 and 6 are positive, so that doesn't matter for us, but we just switch the position right there. The 4 and 7 does not switch positions, but they have negatives involved right there. So there's a negative. Okay, so that's the setup right here. Now we're going to take 1 over 20, that fraction, and we're going to multiply it to each of the cells in here. So I have 1 over 20 times 6 should then become 6 over 20, right? That's going to be the setup right here. Then 1 over 20 times -4 becomes -4 over 20. Now obviously we're going to have to reduce these fractions, but for right now we're just going to distribute them. Okay, 1 over 20 times -7 is -7 over 20. 1 over 20 times 8 is 8 over 20. Okay, so again, all I did was I distribute to each one of those guys right there, and that's this setup right here. To finalize your answer, you do have to simplify it. So 6 and 20 can be simplified, so can 4, -4 and 20. 7 and 20 cannot be simplified because 7 is an odd number, and then 8 and 20 can be simplified. So when we simplify it, your final answer becomes 3 over 10, -1 over 5, again, that -7 over 20 stays, and then 2 over 5 is your final answer. So this is now the inverse matrix right there. So that's your final answer right there. Okay? So let's try example 2. Example 2 I have is 0, -1, 2, and 5. So again, the first step is to find the determinant of the second order. So we're going to cross multiply right here, the 0, 5, subtract it from here. But I also have a negative in here. I purposely put a negative in there. So then you have is a minus right there and a negative, right? So that gives us a positive. And 0 times anything is 0. So your final answer is 2 is the determinant. So now the inverse. When you set this inverse up, it becomes 1 over 2. And then again, you switch the 0 and the 5 positions. Switch the positions. The 1, -1 becomes +1 now. Because remember, it's the opposite sign. And then the +2 becomes -2. And it's the opposite sign right there. Okay? So now I take the half and I distribute to each one of these. So half times 5 should be 5 over 2. Half times 1 should be half. Half times -2 is going to be -2, right? Over 2. We're going to keep it for right now that way, and then we also will simplify it. But if you want to go ahead and simplify it, you're welcome to simplify it right there. So half times 0 obviously is 0, but we're going to put 0 over 2. So when we do simplify it, just the bottom will be simplified because it's negative 2 over 2 is negative 1. 0 divided by any number becomes 0 right there. Okay? And again, this is your final answer. So if you could do some of that simplifying right there ahead of time, then you won't have to have this middle step right there. You'll just get straight into the final answer. All right? Okay, last example, example 3. I have is 0, 4, 0, negative 7. To find the determinant again, we multiply across and subtract it from the other direction. So we have something like this, and final answer becomes 0, obviously, because 0 times anything is 0, 0 times anything is 0, so final answer is 0. Now, to find the inverse. The inverse is going to be, obviously, 1 over determinant. In our case, determinant was 0. Okay, so we put in 0, and then I'm going to go ahead and switch these guys right here, the positions, switch the positions right there, opposite signs right there, right? You can't have a negative on a 0, so 0 is neutral, it's not positive or negative, so we'll just leave it as 0 right there, okay? So when I'm ready to distribute this, here's our problem. We have this 1 divided by 0. When we have any number divided by 0, we have learned from this year that it is undefined, right? So in this case, I cannot distribute this to each one of this, so we're actually done with this problem, and we're just going to put does not exist because obviously 1 divided by 0 is undefined, so you can't distribute undefined, okay? So that's what we're going to work on now, is finding the inverse of the function.